Welcome to the Asking the Experts podcast, where every day is a good day to ask a question. This podcast is provided by the Adaptive Silviculture for Climate Change, or ASK Network, which is a collaborative effort to establish a series of experimental silvicultural trials across different forest ecosystems in the United States and Canada. In each episode, we bring you up-to-date findings from natural resource professionals who are conducting applied research related to climate adaptation and ecosystem management. We hope that platforming these individuals and their work will lead to a more widespread understanding of the importance of climate adaptive management and improved ecological outcomes in North American ecosystems. Thank you for tuning in. Hi everyone, this is your host Riley McMillan, and today I'm here with Dr. Adrienne Keller, who is a terrestrial ecosystem ecologist and soil carbon scientist associated with Michigan Tech University and the Northern Institute of Applied Climate Science, aka NIACS. Adrienne's work addresses how social, ecological, and climatic factors interact with land management approaches to affect how ecosystems function. Her research is often focused on carbon cycling and on exploring how management can mitigate the effects of climate change in many systems. These include forests, savannas, grasslands, wetlands, agricultural systems, and urban systems. Much of Adrienne's work is informed through collaboration with natural resource professionals and public stakeholders, and she's an active proponent of science engagement and communication in her field. Thank you for joining me today, Adrienne, for what I'm sure will be an informative and interesting interview. So today's conversation is going to focus on your work related to above and below ground forest carbon. To get us started, can you give us a brief overview of your career trajectory and describe your interest in this field and in natural resources generally?
Sure. So I think like a lot of folks, my career trajectory has been a windy one with plenty of speed bumps and slight redirections along the way. But as I look back, I think that there are some consistent themes that continue to ground my work. So for one, I have a deep love for nature. I have a curiosity in understanding natural processes as well as humans' connection to nature. And I also have this zest for sharing my curiosity and my knowledge gained through research to others, whether that's through classroom teaching, talking with land managers, or providing tools and information to a variety of interested parties. And so if we roll back to my childhood, I spent most of my childhood in Oregon, and I have this picture of me digging in the dirt in a forest patch by my house. And I think that that really encapsulates a lot of my career trajectory, starting just digging in the dirt, loving to be outside and curious about what is beneath our feet, not just what we can see above ground. And so there's this forest patch near my house that also emulated another key component, I think, that describes my personality, and that's freedom. And so a lot of my connection to nature was this desire to have freedom, to be able to explore, to get outside the confines that we often work in our built environment, and just be able to walk a quarter of a mile away from my house as a young kid and run around and explore the forest. And I also spent my childhood growing up and almost every night asking my dad before I went to bed to tell me something interesting that I don't know. And that really, again, emulates sort of my interest in science and curiosity. And as I got older, I really put this scientific curiosity together with my love for nature. And I also started to think about and see some of the effects of climate change and other anthropogenic impacts as I got older. Although honestly, I think that my thinking and understanding about human effects on ecosystems probably started by thinking about ecosystems that were far away from my hometown in Oregon. I remember growing up in the 1990s in elementary school, we had, a fund to raise money to save the rainforest. And I've been so lucky throughout my life to have been able to explore these really diverse landscapes. So I've been able to go to those neotropical rainforests. I've been able to go to the sub-Saharan savannas, been able to scuba dive in the Great Barrier Reef and other places. I'm just this nomadic explorer at heart, and I just can't stay put. And so I think being able to see all those different ecosystems, and as I've become more trained as a scientist, really understand the connection between climate change and how that's threatening these diverse ecosystems, that's really gotten me excited about trying to do my small part to better understand how climate change is affecting these ecosystems and what we can do with it. And so a lot of my professional work really bridges these two core components of wanting to understand how and why things work. And like I said, wanting to play this small part, whatever small part I can, to address the environmental and climate crisis that we're in. And so coming back to that picture of me digging in the dirt, I've been particularly drawn to understanding some of the hidden components of our ecosystem. I started asking questions in my research about, for example, how do different tree species influence what's going on below ground? How do different tree species affect soil carbon and nitrogen cycling? And learning about the importance of soils for healthy ecosystems, I started to think about their importance both in climate adaptation and climate mitigation. So I've seen a lot of work in the research world that's focused on soils and soil processes. And in the silvicultural world, there's a lot of focus on tree species dynamics and dynamics of plant biomass above ground. But I'm really enthralled in thinking about the connection between the two, and how do above ground processes and dynamics that we can see really connect to that below ground world of plants, soils, and the microbial communities in the soils that interact with each other to affect how ecosystems function.
Thanks for sharing that, Adrienne. I really like how you're able to connect the experiences you had out in nature as a kid to the work that you do now. I think that a lot of folks involved or interested in natural resources have these really intimate and important experiences as children, where they get to test out their curiosity and explore what's going on in the natural world. And those connections they form can lead them to pursue science and stewardship-based careers like you have. It's also really cool to hear about how your interactions with places and resources beyond your hometown shaped your understanding of climate change. So it sounds like you've had a connection to the natural world and to soil specifically since childhood. I know a lot of your work now centers on soil carbon and understanding how it cycles and how to manage for it. I also recognize that a lot of folks struggle to see the vitality of soils. Most people tend to interact with them less, and they don't have a clear understanding of how they affect things above ground. So, to help ground our conversation, no pun intended, can you share with our listeners why you're passionate about soils and soil carbon specifically? Why are soils so important in your eyes?
For sure. So I think soils are both really fascinating, they're really complex, and they're really important. So they're literally the foundation of terrestrial life, right? And in the context of climate change and greenhouse gas mitigation, soils play a major role. So there's a fact that's often thrown around to emphasize this point that globally, soils store more carbon than the atmosphere and vegetation combined. And so I like that fact because I think it really demonstrates the importance of soils in terms of their ability to store carbon. But soils are more than just stores of carbon, right? As I mentioned, they're this foundation of life where they really help support that world above ground that we tend to interact with more, as you mentioned. So there's lots of carbon that's stored in soils. And in particular, forests store a lot of carbon in their soils. And so because of that, people are really gaining interest in this topic as we see the need to use our natural and working lands to help address the climate crisis and store carbon to keep it out of the atmosphere. And I think this is great on one hand, but it comes with a responsibility for both the research and the practitioner community to deepen our understanding of forest soils and their role in climate mitigation and climate adaptation, as well as to effectively communicate the knowledge that we're gaining about forest carbon cycling to the management and the policy communities. And I think as we continue to live in a capitalist society, there's always going to be pressures to monetize nature. And I think that this can lead to some very dangerous roads that are not climate adaptive and do not promote healthy ecosystems for nature or for human beings if we're not being proactive, creative, and courageous in our work. So in that context, let's dig down into the roles of soils in climate mitigation. So soils store a lot of carbon, as well as the carbon that's in those soils tends to stick around for longer than it might in your above ground biomass. So that carbon that's stored in the soil, some of it is going to be released back into the atmosphere quickly, but a lot of it is going to stick around for decades to even millennia in some cases. And so this is what we call the soil carbon sink. So it's being stored in that sink for a long time. On the other hand, because it doesn't turn over very quickly, it's also hard to build more carbon in the soil over time. And so the potential to really increase that soil carbon sink over years to even decades is fairly minimal. So understandably, most of the focus on forest carbon is on that above ground carbon or plant biomass. I always like to remind people, particularly foresters and other natural resource professionals that tend to think about above ground plant biomass, that plant biomass is really just approximately 50% carbon. So if you think about plant biomass, you think about carbon, whether you know it or not. And so there tends to be a focus on above ground carbon. And that makes sense because this is the carbon pool that we're managing and that also turns over on management relevant timescales. So your above ground carbon or above ground biomass, whether it's your leaf litter that's turning over annually to on decadal timescales, and then that woody tissue is again turning over on decadal timescales in most cases. And so while we tend to think about and manage for forest carbon by focusing on that above ground biomass, it's really important to also recognize that a lot of the carbon stored in the forest is below ground in the soils.
Thanks, Adrienne. I appreciate that you mentioned the monetization or commodification of carbon storage. I've been hearing and learning a lot more about this topic in connection to things like carbon credits. And I think it's really important that we share the information we have about these systems and how they work so that folks can understand the benefits and drawbacks of monetizing nature. I also like how you pointed out the differences between above and below ground carbon pools, especially related to timescales. It makes sense that it might be easier for managers to understand how above ground carbon works, given their familiarity with those timescales, whereas soil carbon might be more of a mystery. So, speaking of mysteries, I want to chat more about some of your work surrounding one of nature's best kept secrets, mycorrhizal fungi. So in the late 2010s and early 2020s, you published several publications related to mycorrhizal fungi and their effects on soil nutrients like carbon. As someone who's particularly interested in these special organisms, I'd love to hear more about your research and the fungi themselves. For those who might not be as familiar, can you explain what mycorrhizal fungi are and what makes them so special?
Sure, Riley, I'm so glad that we share a love for fungi. So fungi, for those of you that don't know, are this really important component of forest soils, and they make up their own kingdom of life. So they're separate from animals, plants, bacteria, and other kingdoms. And you may first think of fungi as mushrooms, which are the fruiting bodies that you see above ground. But much of the biomass of fungi are below ground. You may be seeing this common thread where I keep trying to bring your eyes below ground and what's going on in that soil. So these fungi can make a vast network of hyphae, which is fungal biomass that's exploring the soil. And mycorrhizal fungi are a category of fungi that associate with plants, whereby the plant feeds the fungi by giving the fungi carbon to grow. And in return, the fungi provide resources to the plant, such as nutrients, primarily nitrogen and phosphorus. These mycorrhizal fungi are so cool because from a plant perspective, you can think about them as extensions of the plant, sort of like really small, even finer than roots that are able to explore these vast resources in the soil. But you can also take the perspective of the soil. So from the perspective of the soil, mycorrhizal fungi are these really important conduits that transfer carbon from the plant to the soil, but they also act to decompose soil organic matter. So from a carbon perspective, mycorrhizal fungi can both add carbon to the soil, and they can also release carbon from the soil to the atmosphere. And so this makes it a little bit challenging to try and understand the net effect of mycorrhizal fungi and soil carbon. And it can vary both across time and across sites. So in addition to mycorrhizal fungi being really important for forest carbon cycling, they can also help plants be more resilient to a changing climate. So for example, mycorrhizal fungi can help increase the drought tolerance or the drought resistance of plants. And climatic changes, such as changes in atmospheric CO2, temperature, or moisture, are going to affect both mycorrhizal fungi and plants. But we poorly understand how those climatic changes are going to affect fungi and plants, perhaps individually, and how those individual responses may affect ecosystem functioning. So changes in the composition of mycorrhizal fungi in the soil, for example, due to climate change, could impact plant productivity and regeneration. But again, this needs a lot more research, and those effects are going to vary by site and through time.
Thanks, Adrienne, for that explanation. I find it really fascinating that mycorrhizal fungi are affected by climate change, like the plants they connect with. I think we tend to perceive the subterranean and above ground worlds as totally separate, with things under the ground being widely unaffected by what goes on up here. Since these fungi have such a strong interconnected relationship with plants, I can see how they would also be deeply affected by the conditions of plants, which is partially determined by climate. So I noticed that some of your works compare two types of mycorrhizal fungi, those being arbuscular and ectomycorrhizal fungi. Can you share what the main differences between those two fungi are and how they affect carbon cycling in forest ecosystems differently?
Yeah, great question. So there's several different broad groups of mycorrhizal fungi, but in temperate forests, we commonly find the two types that you just described, arbuscular and ectomycorrhizal fungi. Just for context, in contrast, in grasslands, we only see arbuscular mycorrhizal fungi because ectomycorrhizal fungi associate with trees but not with grasses and forbs. There's been some interesting research trying to assess if and how these two groups of mycorrhizal fungi, arbuscular and ectomycorrhizal fungi, have distinct effects on forest ecosystem functioning. And part of the goal of this work is recognizing that the diversity of mycorrhizal fungi is vast and trying to understand individual species effects of different either arbuscular or mycorrhizal fungi on ecosystem processes is at this point an insurmountable challenge. But we can take these two groups that appear to have a distinct suite of traits and think about how those two groups might broadly and differently influence forest ecosystem functioning. And so the idea is to see if the type of mycorrhizal fungi that dominates a forest is indicative of a broader suite of characteristics that describe how the forest is functioning. For example, there is some evidence that forests that are dominated by tree species that associate with arbuscular mycorrhizal fungi. So these trees include maples, elms, ashes, tulip poplars, for example. That these forests that are dominated by arbuscular mycorrhizal fungi tend to have faster and more open nutrient cycles. And this could indicate that these forests, which are more nutrient rich, may also be more susceptible to nutrient losses. So in these forests, big precipitation events, for example, might lead to greater nutrient losses into the watershed or into the atmosphere compared to forests that are dominated by tree species associated with the ectomycorrhizal fungi. So ectomycorrhizal fungi tend to associate with different types of tree species, such as oaks, hickories, and many conifer species. And one unique aspect of the ectomycorrhizal fungi is that they form these really extensive hyphal networks below ground. So I encourage our listeners to go look at some pictures online that show some of those hyphal networks. So some of my work has explored this broad question of how carbon and nitrogen cycling varies at the stand scale, depending on the type of mycorrhizal fungi, whether it's arbuscular or ectomycorrhizal fungi that is dominant. And one of the cool results that I found, and this connects to our earlier discussion about the importance of soil carbon storage, is that across forests in the eastern United States, forests that were dominated by arbuscular mycorrhizal fungi had more carbon that was being transferred from the plant roots to the soil compared to those forest stands that were dominated by ectomycorrhizal fungi. And even more importantly, from a climate mitigation perspective, the carbon coming from plants in those arbuscular mycorrhizal dominated forests was being stored in soil carbon pools that stick around for a long period of time. So we talked about how some soil carbon tends to stick around for decades or longer. It looks like in some of these arbuscular mycorrhizal dominated forest stands, more carbon is going from the plant to the soil, and a lot of that carbon is sticking around for longer periods of time.
Thanks, Adrienne. Those differences you outlined are really interesting, and I like how you connected us back to forest carbon. It's really cool that these fungi plant associations can be species or functional group specific, and also how stands dominated by arbuscular mycorrhizal fungi sequester more carbon for longer. While I could go on and on talking to you about these funky fungi, I'd like to transition now to discussing about managers' interest in forest carbon and how you navigate management-related conversations. So, in recent years, I've seen an uptick in the number of individuals and organizations who are interested in understanding and utilizing forest carbon to their advantage. From your earlier response, it sounds like you've seen something similar. Is that true? And if so, can you speak to why managers might be more interested in forest carbon today compared to in the past?
Yes, thanks, Riley. I also have experienced and observed that increase in interest in forest managers trying to think about how can we use our forests to help mitigate the climate crisis and draw down some of the carbon that's in the atmosphere and store it in forest biomass and forest soils. And this is driven again by that idea that our lands, our natural and working lands, including our forests, are serving as this sink for carbon. And so our atmospheric concentrations of carbon dioxide would be much higher if we got rid of all of our forests. So they're playing an important role of helping mitigate these rising atmospheric carbon dioxide and other greenhouse gas concentrations that are leading to the effects of climate change. And so, as I mentioned before, there's lots of carbon stored in our forests in the United States, and particularly in our soils in forests. And we're releasing more carbon into the atmosphere than our forests can absorb due to fossil fuel emissions primarily. And this is contributing, right, to climate change. And so I always like when I start talking with natural resource professionals, I like to come back to what is the forest carbon cycle. And I like to emphasize that the forest carbon cycle is just that. It is a cycle whereby carbon naturally cycles from the atmosphere to the land and back to the atmosphere. And disturbances, such as wind events, as well as harvested wood products, they can alter the timing at which carbon returns to the atmosphere. For example, a stand replacing fire may return a large pulse of carbon into the atmosphere quickly, whereas in the absence of such a disturbance, this carbon would more gradually be released to the atmosphere through decomposition. And what I just described is the natural or biogenic forest carbon cycle. And I'd like to sharply contrast that with the fossil fuel carbon cycle. When we use fossil fuels, we are moving fossil carbon that has been locked away out of the atmosphere for a million or more years. And we're moving that fossil carbon into the atmosphere and into this active carbon cycle. So this unlocking of fossil carbon into the atmosphere is the main driver of climate change, along with land use change, such as converting a forest to an ag land or to urban development. And that's quite different than slightly altering the rate of forest carbon cycling when we cut down a tree, but we're still maintaining that forest as forest. And so to your question about the increasing interest in forest carbon management, I think there's this interest to understand better how to maintain and increase the ability of forests to take up and store carbon as a means to mitigating or offsetting the rising concentrations of carbon dioxide and other greenhouse gases in the atmosphere. And there's a term that the US Forest Service has been using, which is carbon stewardship. And this term hasn't been concretely defined, but there are some principles of carbon stewardship that have been identified. And I can go through those today to give people a sense of what carbon stewardship really embodies. So the first principle of carbon stewardship is thinking about timescale, and we've already touched on this a little bit, where the carbon benefits of any management action could be quite immediate. It could be increased above ground biomass growth, or it could be realized over decades. And so that could be increased soil carbon storage over many decades, because as we talked about, it's hard to accrue more carbon in the soil over short time periods. So in addition to timescale, a second principle of carbon stewardship is stability. And this is really important when we're thinking about managing our forests for carbon benefits over the long term, thinking about how long that carbon will persist in the ecosystem. And again, that was something that we just talked about in terms of this difference between arbuscular and ectomycorrhizal forest contributions to forest carbon cycling and really thinking about how long that carbon is going to stay in that ecosystem before it is released back into the atmosphere. Of course, the longer that the carbon stays in the ecosystem before it returns to the atmosphere, the greater capacity it has to mitigate current atmospheric concentrations of greenhouse gases. So the third principle of carbon stewardship is considering climate adaptation, which of course is very in line with the general theme of your podcast and the Adaptive Silviculture for Climate Change network. And it's important to recognize that not all adaptation actions will provide carbon benefits, but many actions that are intended to reduce risks to ecosystem health will help sustain or improve the capacity of ecosystems to sequester carbon into the future. And so this is linked to those ideas of timescale and stability. And the fourth principle is, I think, really important that is often overlooked, and that is that the goal of carbon stewardship is to optimize carbon rather than maximizing carbon storage and uptake. And so this is really taking a holistic approach to thinking about the various different benefits and the different functions of a forest, one of which, but not the only one, is carbon storage and uptake. And recognizing that our forests are this holistic system, and it also aligns with the ethic of the US Forest Service, which is to manage our forests for multiple benefits. And so overall, this idea of forest carbon stewardship is a concept that aligns with both this Forest Service mission of managing for multiple uses and objectives, and I think is a really nice way to think about how can we use our forests to help mitigate our climate crisis, while also recognizing that our forests are complex and serve a variety of different needs. And so how much carbon a forest currently stores varies by a suite of different factors. And this can include tree species composition and age, climate, soil type, among other factors. And how much carbon the forest will continue to take up and store into the future is increasingly hard to predict due to the increasing frequency and intensity of disturbances such as drought, fire, disease, wind throw, etc. And so carbon stewardship must take into account this changing disturbance regime as we're trying to think about the value of our forests in a carbon and climate mitigation context.
Great. Thanks for sharing that, Adrienne. I like how you broke that down. That, put simply, carbon cycles, like a lot of other things in our environment. And that managing for carbon means understanding those cycles and using the resources we have to adjust those cycles accordingly. I also appreciate how you outlined the principles of carbon stewardship and addressed how people are thinking about it today. I think lots of managers, federally employed or otherwise, are interested in managing for multiple uses and could generally apply these principles to their management efforts if carbon is something that they want to steward. Now, I want to touch on something you mentioned towards the end of your response. You said that it's becoming harder to predict how carbon will cycle in a given forest due to climate change and shifting disturbance regimes. You also referenced this uncertainty earlier on in the context of mycorrhizal fungi. So it sounds like this concept of unpredictability is something that's pretty intrinsic to your work. I imagine that that can make the managers that you work with nervous at times. So I'm wondering, can you describe how you justify the need for carbon stewardship to managers despite the uncertainty that exists?
Sure. So when I'm talking with managers about forest carbon management, it's usually because they're really interested in thinking about how to use their land for climate mitigation. And so I usually like to take a step back and, as I mentioned before, really think about what is the forest carbon cycle and how can we consider, as you said, this increasing uncertainty that we're working with, right? So we can't with certainty estimate exactly how much carbon is going to be taken up and stored in any given forest in the future. We can't project this into the future, even tomorrow, let alone in 10, 50 years. And so I start by encouraging managers to come back to the key principles of how the carbon cycle works. Now, as I mentioned earlier, I have found that natural resource practitioners have a vast knowledge about their site and about how forests work, but aren't necessarily as comfortable and as confident thinking about the carbon cycle explicitly. And so I like to remind them to come back to those very basic principles of forest carbon cycling. I break up the forest carbon cycle into some key pools and fluxes. So that's pools or areas that carbon is stored in the forest. So above ground biomass, that's what you can see in your trunks and your leaves. Below ground plant biomass, your roots, your soil carbon pools, which we already talked about, as well as your dead wood and your litter layer, your organic matter on the forest floor. So those are the dominant pools that we like to talk about when we're thinking about forest carbon, where forest carbon is stored in a forest. And then fluxes, or the movement of carbon between those pools, is also important to think about. And so when you have carbon in biomass, a lot of that carbon is eventually going to get transferred either into the soil and be stored for longer periods of time. Perhaps it will be transferred to that deadwood pool, and some of it is going to be released back into the atmosphere through decomposition. And so just thinking about some of these carbon pools and the movement of carbon within a forest, I think gives natural resource professionals a handle on how to think about how carbon is going to move through their forests and in and out of their forests over time. And then that gives them a framework for which to think, okay, if a fire comes in or a wind event comes in, how is that going to affect each of these pools and the movement between these pools? So if you think about a low intensity fire, for example, you're going to come in and you may have some reduction in your above ground biomass that perhaps is going to move into the deadwood pool, right? Some of it is also going to get combusted and released back into the atmosphere. So you will have a pulse of carbon from that above ground pool and perhaps that forest floor litter layer pool into the atmosphere. But you're also going to have an increased flux from your plant biomass pool into your deadwood. And eventually some of that is going to go into your soil pool. And so these are the kind of conversations that I have with forest managers that are trying to understand the interaction between increased disturbance and stress due to climate change and forest carbon storage and future uptake. And so a lot of times there's an interest in getting an exact number. How many carbon molecules do I have today and how many am I going to have next year? Right now, it's pretty hard to do that with any degree of certainty, especially really at any scale, but oftentimes folks are interested in getting an estimate for their specific stand or their specific forest site. And so some work I've done in a collaborative project with the Nature Conservancy recently has been to sort of step back and think, we don't necessarily need to know exactly how many carbon molecules are in our nature preserve, but we want to get a sense of, is our carbon going up or down? And how do we expect with a given active management practice, it'll affect carbon as well as some of our other management goals? And so in this project with the Nature Conservancy that we carried out in the Meyer Preserve in southeastern Wisconsin, we thought, instead of trying to quantitatively understand the number of carbon molecules, we thought more qualitatively, right? So the direction and the magnitude at which carbon was going to change due to different management practices. And we thought qualitatively about these different carbon pools because, like I said before, active management, let's say a thinning practice, is going to affect your above ground biomass, right? You're literally taking above ground biomass away, but it isn't going to have as much of an effect on your soil carbon pools, for example. And so helping land managers, including those at the Nature Conservancy on the Meyer Preserve, use this framework of different carbon pools to be able to think about the qualitative, again, both the direction and the magnitude of change was really helpful. And that project was really thinking about, how do we consider both carbon management goals alongside other management goals? In this case, plant biodiversity. So this preserve had goals to both maintain and increase native plant biodiversity, as well as think about potential for maintaining and increasing carbon stores. And what we came out of using this qualitative exercise was we identified where you might have some small carbon losses but you'd have big gains for plant biodiversity. And so I think that's where the magnitude of the change is really important to consider, is not just saying, oh, you're going to have carbon losses, but okay, those carbon losses are actually going to be quite small compared to some of the plant biodiversity gains that we may see that are quite large. And the other, I think, important component that came out of that work was recognizing that on different patches of land across a site, you might optimize for different goals. So there were places at that preserve where it actually made sense to really try and focus on the carbon goals, because those plant biodiversity goals were going to be a lot harder to achieve. And other places where it made more sense to really focus on those biodiversity goals, and carbon could be a secondary goal. And so that's one example of a project where we tried to help land managers think about how to manage for carbon alongside other management goals, and recognizing some of those trade-offs while recognizing that we're working in an uncertain world. And so that all had to take place within the context of recognizing the importance of climate adaptive management practices.
Awesome. Thanks, Adrienne, for that explanation and really cool example. I like how you're able to simplify what can seem like a really complicated process and view it through a more qualitative lens. And at the same time, it sounds like you're still able to be site-specific or maybe even patch-specific in how you're directing change. As a student of natural resources and ecology, I've learned that it depends is really the number one rule of the natural world and subsequently management. And that because of the natural variability that exists, managers must apply different strategies and approaches in different patches to achieve desired outcomes. Whether their goals relate to carbon or another factor like biodiversity, success comes with being adaptive and making informed decisions that are specific to one site's situation and needs. And there's also this element of choice, like you shared, in connection to unavoidable trade-offs. Going off of that, I'd like to talk more about this process of determining and assessing trade-offs in the context of carbon stewardship. As you mentioned, carbon is just one of the things that people are interested in managing for, and other goals can sometimes take priority in one location versus another. Given that, I bet communicating about those trade-offs is a really critical part of your work. Can you share a bit more about how you talk with managers about trade-offs related to carbon and/or climate change? And maybe how you've operationalized some of those discussions?
Sure. So I think it's first important to compare management to management without climate adaptation. So stepping back and thinking about, if we didn't consider climate in our management planning and management actions, what would that result in? And often that leads to increased mortality from canopy closure and overcrowding, reduced diversity that can lead to increased disease and vulnerability to disturbance and climatic extremes more broadly. And so that's a first place to conceptually start from, is comparing that climate adaptive management to maladaptive practices. From there, I really, again, like to come back to this idea that you can manage for different things in different patches, just like you highlighted. And I think that is often a nice pressure release valve for practitioners to realize that they can focus in on one goal in one small area and focus in on a different goal in a different area. And so just give you a little bit more of an in-depth example from that Nature Conservancy project. So we were managing for oak savannas in the example that I'll give. And there was one patch of the preserve that had really beautiful old oak trees with nice understory herbaceous layer, really indicative of a healthy oak savanna. And that was a place where it really made sense to continue to manage with prescribed fire for plant biodiversity, specifically oak savanna dependent plant biodiversity. And then if we looked at another patch of land that was really not geographically far away from that beautiful oak savanna, there was an area that had already gone through mesification. So it had become a lot wetter, and oaks really were no longer competitive there. And that forest now looked nothing like an oak savanna, and instead looked like a young secondary forest that was dominated by maples. And so that was an area where it would have taken an extreme amount of active management to even try and revert that back to an oak savanna. But there's actually quite a lot of carbon uptake and potential future carbon storage at that site. So we had these young trees that were growing fast, taking up carbon. And that was a place that really made sense to prioritize these carbon management goals at the loss of focusing on the plant biodiversity goals. And so that's just one example of how managing patch by patch and for different goals, whereas at the landscape, you're still able to achieve your various different management goals. And finally, I think we've touched on this a few times in our conversation today, but there's this increased need for, I think, carbon competency and confidence amongst practitioners. And I just want to reiterate again, my work over the last few years with land managers has really awed me in their ability to understand their local site. And I think that is so critical. And that type of knowledge at the ground is so important. And when we're thinking about climate adaptive management. But I think that something that's often missing is that competency and even more importantly, that confidence in talking about forest carbon. And that's really important when we're trying to bridge policy that's often coming down at higher levels with on the ground management.
Great. Thank you, Adrienne. Your work with the Nature Conservancy really showcases how adaptive management can be successful and support diverse goals. I also definitely agree with you about the value of place-based knowledge, which managers often have. At the Ask Network, we really rely on practitioners with awesome site-specific knowledge who know everything from the time it's going to rain to the name of the bugs on the ground. And their hard work and connection to the land is truly invaluable since it informs how general truths about, for example, carbon sequestration can be applied to a specific location. In your response, though, you mentioned that some folks might lack this carbon competency or carbon confidence that could further inform decision-making. Given that, I'm curious, have you identified any knowledge gaps had by managers generally related to carbon? If so, have you or your colleagues done any work to address those gaps?
Great question. One thing that I think we've done effectively in either one-on-one conversations, workshops, even webinars, is helping natural resource professionals just practice talking about carbon. I think in this highly politicized world where carbon, like we've mentioned, is trying to be monetized, it can feel like a real pressured environment to say the right thing and have a lot of technical knowledge about carbon. And while at its most basic, forest carbon cycling is quite simple. When you dig down into the weeds, it does get complicated. And that gets back to the challenge that we mentioned of trying to really fully put down a number for how much carbon is in a given site. But at its most basic, carbon cycling is pretty simple. And again, it is plant biomass if we're thinking about the plant side of forest carbon cycling. And then, of course, soils also store a lot of carbon. And so I think just providing opportunities in low pressure environments for forest managers to talk with experts in the room like myself, talk about carbon cycling, I think that's really helped. And I've also identified over the last couple of years some key points that are these knowledge gaps where natural resource professionals have heard things like the importance of mycorrhizal fungi and the importance of soils and storing carbon, but don't necessarily have some depth of knowledge in those particular areas. And so to that end, I and some colleagues developed a series of primers that have just been, sort of extended fact sheets, a couple of pages that are essentially synthesizing the research about these different topics, but in a way that's fully accessible to practitioners on the ground. And so we published primers that are available for free online about soil carbon, about earthworm effects on soil carbon cycling, about carbon cycling in wetlands, and about fire effects on carbon cycling. And so those primers are an example of a way that we try and connect the research with on the ground management.
Wow, those sound like awesome resources, and I'll be sure to link some of them in the show notes for this episode. Again, I really like how you're able to translate these complicated and sometimes technical concepts into more digestible formats like webinars and short documents. The pressure to know and say the right things about any topic, but especially climate change, can be overwhelming. So I think it's really cool how you're giving people the opportunity to increase their knowledge about that topic and be better prepared for those difficult conversations. It's clear that you're a very talented science communicator who's passionate about connecting people to the information they need to succeed. Given that, I'd like to chat briefly about your perspective on the value of science communication and outreach in your field and others. So, in your 2020 paper, Engaged Science Strategies, Opportunities, and Benefits, you and your co authors shared that efforts to enhance and harmonize engagement efforts will have multifaceted benefits. Expanding on your work in that paper, can you speak about some of the benefits of engaging with managers to share science that you've observed?
Yes, I love this question. So, as an inherently curious person, I love talking with different people from different backgrounds with different areas of expertise. And what I found is if I go in with humility and being okay with not knowing a lot of things and being ready to ask questions, I learn so much more, and it really enriches both my broader life experience and my research. It can help guide where my research goes, and it can help me understand the connection between my research and some of the on the ground practicalities. And so, in that way, it really diversifies the ideas that I have and the broader community that I'm a part of professionally. And so, it's been a really fun personal opportunity for me to be able to engage with managers. And again, it really, I think, also expands and enhances the research that I'm able to do because I understand that connection. I come from one very limited background. And so being able to connect with folks that have a different background and a different area of expertise and perspective, when they walk into a forest, they see something slightly different than I see something. And that has really been personally and professionally rewarding for me. And as I mentioned before, being with people that have on the ground knowledge really informs how that research is going to get translated into on the ground action and broadly decision making. And so I like to just approach it as we all know something and none of us know everything. And if we can come together, I think we can do some of that really creative and courageous work that I mentioned earlier, I think is important if we want to solve these huge crises like our climate crisis today.
Thank you for sharing that, Adrienne. I completely agree that getting to engage with folks about what they know is super personally and professionally rewarding. After all, that's what this podcast is all about. I've learned that everyone has interesting experience and knowledge to share, and that so many folks are engaged in that creative and courageous work that you mentioned. Anyways, I really loved having you on today and getting to hear more about your courageous work in the field of forest carbon. In closing, I'd appreciate if you could share a little bit about what makes you optimistic about the future of the systems you care about, especially in the context of our changing climate. Is there anything you've researched, heard, or experienced that brings you hope in your field?
Thanks, Riley. I think this is a really important question and something I've been reflecting on a lot recently. And as I've gotten older, I've had the opportunity to meet people from lots of different backgrounds, different geographies around the world, different life challenges and experiences, and different passions. But one thing that I think I see many of us share is this connection to nature. And I think not to sugarcoat it, I think in many cases, our daily lives do detach us from nature. I mean, you and I here are talking not in a beautiful forest, unfortunately, but in our offices. But I think that there is an increasing focus and interest on reconnecting or deepening the relationships that we each have with nature. And so for me, I try and start every day by getting out and enjoying some fresh air, whether that's just a quick walk around the block or a nice cross-country ski or run outside or a bike ride to work. And that really helps ground me before I get to work and start thinking about what can I do with my research to try and address the climate crisis. And so I think that's one thing that brings me hope is that in a very divided world in a lot of ways, that I think if we are able to tap into some of our commonalities, one being that connection to nature, that's going to help us really understand where our priorities lie. And hopefully developing that stronger connection to nature will help us prioritize that more over some of the other distractions in our world. And people like you that are doing really cool, passionate work also give me a lot of hope. And so I just thank you for the opportunity and all the work you're doing with this podcast.
Thanks, Adrienne. Your work also gives me hope, and you've inspired me to try extra hard this week to get outside and to connect more deeply with nature. So that brings us to the end of our time, but before we sign off, is there anything else that you'd like to plug for our listeners to check out?
Thanks, Riley. We talked about some of my research and projects, and Riley, you may want to share some of those in the show notes, but folks can also reach out to me directly and learn more about my research on my website, which is adriennebkeller.com. We have a peer-reviewed research paper that's coming out about that Nature Conservancy project. It's not published yet. We also have some various materials to help people think about and communicate about carbon with confidence. Connect with me about those if that's of interest. But I just want to say thanks again, Riley. It was a pleasure getting to share some of my work and some of my thoughts with you today.
Great. Thanks again, Adrienne, for coming on the podcast today and sharing your time and insight with us. This has been an amazing conversation, and I'm excited to continue researching the topics we discussed off air. Thank you to our listeners for being here today. Be sure to tune in 2 weeks for our next episode, which will feature a discussion with Dr. Martha Sample about the effects of climate change and beetles on lowland hardwood forest systems in the upper Midwest. Talk with you all soon, and happy holidays.